at another example. We've got another curve defined by the parametric equations x equaling sine t and y equaling sine 2t, where we're told that t is greater than or equal to minus pi over 2, but less than or equal to pi over 2. We're asked to find a Cartesian equation, so equation just involving x and y in the form where y is some function of x. And we're also to specify the domain of that, giving a value of k, where we're told that this function has a domain between negative k and k. Pause the video and think about what you might do. You might even want to have a go at this problem. It's another one that's borrowed from the textbook, but try and avoid peeking. Right, so what you should have done, and I've probably left too obvious a clue perhaps down here, is for, well, I've got sine 2t, so if I remember my double angle formula, maybe that's a good starting point. So you should have remembered that if you've got y equaling sine 2t, then that must mean that's equal to 2 sine t cos t. Now this is good because we actually already know that sine t is equal to x, so I could write x here. The issue, of course, though, is that we've got cos t here. So what are we going to do about that? Well, we know that sine squared t plus cos squared t is equal to 1. Well, if I was trying to make cos t a subject here, then I could say that cos squared t is equal to 1 minus sine squared t, and so that cos t is equal to the square root of 1 minus sine squared t. But you might be thinking, how do I know that this is positive? Why hasn't Sir written plus or minus? And I suppose, strictly speaking, I should have written plus or minus here, but let's have a look at the domain. That this is between t, with t, we're told that t is between minus pi over 2 and positive pi over 2. If I did a quick sketch of my astyc diagram, all sine, tan, cos, in that domain from 0 to pi over 2 and 0 to minus pi over 2, both of these quadrants in our cast diagram have a positive cosine, so it must be that cos t is positive, and so that it's equal to the square root of 1 minus sine squared t. The textbook's not very good at glossing over that, and I know it can be something that trips people up who are really thoroughly thinking about this, so well done if you spotted that. Right, excellent. Now we know that cos t is 1 minus sine squared t, we can substitute all this in, can't we? Because we've got everything ultimately in terms of sine, which we know is what x is equal to. So I can write that y is equal to 2x times by square root of 1 minus my x squared. Issue is I've not stated my domain yet, have I? Well, remember the domain of y is equal to a function of x is going to be equal to the range of x, which is given as a function of t. So if we find the range of this, it will tell us what the domain is of our new function. This makes sense because we're ultimately putting x into this function, so we just need to consider what values of x that this function can take. Well, we've got to consider sine t within this domain. So if I could do another sketch of a stochastic diagram if I'm not too sure. I could sketch my sine graph if I prefer not to use an astyc diagram. Alright, so we've got to go from negative pi over 2 positive pi over 2, and that's going to take me from a value of minus 1 to positive 1 in my sine, or viewing it in our old way of expressing a trig function, we know our sine within that domain for t would look like this. So it must be that x can take a value between positive 1 and negative 1, as the sine value can take a value between positive 1 and negative 1. and that must mean that if x is between or equal to 1 and negative 1, my k is equal to 1. So my x must be able to take a value between 1 and negative 1, my k must be take a value equal to 1. Just watch out for that though. Oh, the last part of this question is asking us find the range of f of x. So the range of f of x is going to be equal to the range of y, and that's the range of y as your new function, which you could consider, but it's also equal to the range that y could take given in terms of t, and it's almost always going to be easier to just consider for t and not for your new function. So just consider what range could this take within this domain. Well, it's sine 2t, so we'd be considering this between pi and negative pi, and so it's going to be the same. It's going to be the same as it happens as the range that your x could take in terms of t. As we've got another sine value, the maximum it's going to be able to take is 1, and the minimum it's going to be able to take is -1. So our range, our function can take, is that our function could take a value between 1 and negative 1. And those are our answers.